Good afternoon. Thank you for allowing me to speak for a few minutes about our company and what we're doing. Hope you all enjoyed your lunch. I'd just like to give you a brief introduction of our company, what we started doing, what we're doing now, and hopefully what we plan to do in the future, and how we came to work with IQRF and what we're doing with them. So the Findlay Irvine was started by two colleagues, James Findlay, John Irving, in 1960. They were part of Ferranti, and to nick a phrase from Hitchhiker's Guide to the Galaxy, they thought transistors were a pretty neat idea. They actually started with something completely unrelated to environmental monitoring, but the family still own and run the business. John Irving, despite being 85, still comes into the company every morning. He's got a very sharp brain, very good at calculations. But the company is now run by his son Colin, and we do all the design, manufacturing, sales and service in-house in a small village called Pennycook, which is about 6 miles south of Edinburgh. And that was their first product. Not environmental detection, but greenhouse heating controls. They were manufacturing 15,000 of those a year in the late 60s, and we still get inquiries even today for the use of them. We still have the records for how to repair them. We still actually use them to heat the factory when it's very cold in Scotland. Our main areas of markets are defence, air, road and rail. Some of them overlap, so weather monitoring applies to both road and air. Skid resistance testing applies to both road and air. And the bulk of our business nowadays is on the railway, which is Network Rail in the UK. The trains are actually owned by separate companies, but Network Rail are responsible for the maintaining and the running of the track, the signalling and the stations. So the defence market we have is very limited. We supply a few control systems for the Astute-class submarines and a few things for the Type 23 frigates, including a helicopter handling system. And the best way of describing that is plain radio-controlled cars with a couple of £1 million helicopter. It's quite fun. We do a number of things called grip testers. These work on spinning a wheel at a different ratio to the drive wheel, so it forces it to try and skid. You put a known amount of water in between the tyre and the surface, and from that you can measure the friction of the road surface. All their runways are required to be tested in relation to the number of flights they handle, so Heathrow have to sample it every couple of days, whereas somewhere like Jersey may only sample it once every 6 months. We also do a portable version to take out to helidecks on oil rigs, and that's shown in the bottom picture. And the results of that come up as a little graph showing whether the friction is good or bad. A lot of the weather stations you see dotted along the motorways in the UK are provided by one of two companies. One of them is us. So we do air temperature, humidity, rainfall. We have road sensors which can work out the amount of chemical on the road surface. So that's used by the local councils and highways authorities to work out whether they need to send out gritters and clear the ice. And that's provided in the form of a website which is called IceAlert, which all the local authorities, highways agencies have a login to. We also get information from the meteorological office which feeds into the calculations that are displayed on the graphs. The bulk of our stuff, as I said, was railway stuff. One of the things we've been doing for about 30 years is points heating and controlling. So we provide heaters which are mounted underneath the track to heat the points to stop them freezing together. And the little unit in the middle there is a monitoring unit which detects the temperature coming back from one of the various sensors, so that it knows what the temperature of the rail is and the temperature of the surrounding. Another thing we do is monitoring of the current going into point motor controllers, so they can detect whether they're seized. Those are done using current transducers. We also have a range of temperature modules, which is the picture on the left-hand middle. So a little block of resin which has a temperature monitor which is clipped onto the track, and that sends a 433 megahertz wireless signal back to a receiver, which tells you the temperature of the rail at that point. Part of the reason for doing that is to detect conditions where the rails may start to buckle. We're also now trialling a system for detecting flooding on the railway line, so we can give them advance warning of where there's areas which is dangerous for a train to go into. In 2014, right at the end of the year, Network Rail came to us and a couple of other companies and said, we have a problem. Sorry, I missed one. Let's go back. So we had an issue. They wanted to monitor these point motors which are used on high-speed rail lines, because obviously you don't want a train derailing when it's doing 125 miles an hour. The units had a data output which is normally used for maintenance. They wanted to actually use that to monitor it in real time. So we came up with a little unit which you can see on the left hand side there with a black dome aerial on it, and that connects to the data port, and that sends wirelessly back to the control station the status of the various parts of the point motor. So it tells whether the points have properly engaged, when they've been moved, the temperatures, the current going used by the motor. So from that they can determine whether part of it is failing and needs to be maintained, or whether it's actually failed completely and it's going to cause a problem. Originally we looked at using the IQRF module for that. Unfortunately, as you can see, it's very close to the ground, and propagation of RF under those circumstances meant with the blue modules, the DCTR52s, at the time they didn't have the range to get 600 metres down the track with that propagation, so unfortunately we had to go with Zigbee at that. But those are now being installed and so far been working very well. And that is a graph of showing how it comes up on their monitoring system. But in December 2014, Network Rail said we have another problem which we need to find an answer to, which is that. When we have landslides in the UK, they tend to be fairly catastrophic and very quick. And if a train hits that, derailing a train is going to be very nasty and very costly, potentially in human lives and certainly in compensation costs. And the Office of Rail Regulation said to the Network Rail people, you need to come up with a way of trying to work out when that's likely to happen and where it's going to happen. And it's not just coming things onto the line, it's the line actually disappearing. Some of you may have seen on the south coast of the UK last year, there was I think it was Dawlish, the underbed of the rail was completely washed away, leaving the lines hanging in midair. No way a train was going to be able to go over that. So they asked us if we could come up with a solution which would do two things. One, give them a warning that a landslide had happened, and secondly, to try and help predict when it might happen, which obviously is two different kettles of fish. So that was the schematic of our proposed solution. It's a pole. We couldn't have any power because they may be in the middle of anywhere. So the system has to be totally self-powered. So the suggestion we came up with was a range of sensors on poles. The idea being if the landslide moves, the poles will move. Each sensor has an accelerometer in it, so it knows the XYZ value from gravity. That reports back to the control box, which is solar powered. The box also has a pair of cameras connected to it which look up and down the track, so that if a landslip is notionally reported, it will then send a picture from the site so that they can have a look at it and see if there's actually a blockage on the track, or whether it's something they can just clear up because it's only gone just down the side of the embankment but hasn't actually blocked the track. So this is what the sensor ended up looking like after about a year of design. I was very fortunate that Vladimir came over in February last year, made quite a few suggestions as to how we could achieve this with the mesh system rather than using the system we had designed in-house. And he also invited me to Hutchin to come to the training course, which was very useful. The accelerometer measures in 3 axes, and it has to be battery powered for 5 years and sealed to IP68. So that was the original design. The first ones we installed, we found to our cost that we hadn't realised the accelerometers, as well as measuring gravity downwards, would react to the movement sideways, and we found that the carbon fibre poles supplied by Network Rail resonate at 22 Hertz. And they move 3 millimetres when a train goes past or when it's very windy. which is obviously not desirable, so we had to go back to the drawing board a little bit, and we put a pick on there now to sample them once a second and average that out. And we also changed the accelerometer to have one with filtering on, which solved the problem. But then that showed another problem, that the temperature coefficient on the accelerometer we chose produced a variation in temperature overnight, which was also unacceptable. So we're now on the third version. So the current sensor looks like that. Normally has a cap on the top, which is sealed, and the inside is filled with gel to make it completely waterproof. The reflective material is so that at night time the infrared cameras reflect the IR lamp off, so you can actually see the sensor at night. And that's what the sensor currently looks like. The battery, the IQRF module, the accelerometer and a pick. Has a magnetic reed switch at the bottom to enable us to control it, turn it on and off, and put it into RF program mode for updating. So the control box looks like that with the cameras, and there you can see on the top right, you can see some of the sensors installed on the poles along the side of the track. And that's a view of the website, which displays all the information. The green means the sensor is in a stable condition, hasn't moved out of tolerance. If it moves more than 5 degrees, it generates an alarm, and that will then send an SMS and an email to whoever's on duty within about 2 minutes of the tilt sensor moving, and that gives them an opportunity to stop trains and have a look and see what's happening. I'll give you a very quick demo of the sensor. I haven't got the box with me because obviously that big box they wouldn't let me bring on the plane, so I'll just demonstrate by plugging in just to test. So you see as I move the sensor around, the angle of tilt changes. That would be reported every minute back to the control point, and that's averaged over a period of time. It uploads from the control box to the website every 2 hours, but if there's an alarm detected, it uploads immediately via GPRS, and also then proceeds to upload the pictures. And if anybody wants a demonstration of the live website later, I'll be happy to show you. Thank you very much.